Chemical kinetics. So first of all, what is chemical kinetics? It's the study of how quickly a reaction occurs, or reaction rates. So you might remember spontaneity. Studied that before our break. Spontaneity is just the tendency for a reaction to occur. It does not indicate how quickly the reaction occurs. So we are now studying the reaction rate, which will tell us how the concentration changes through time. So just don't get confused that spontaneity is the rate of the reaction, because it is not. So what is reaction rate? So it's that change in concentration of the reactant or product over time. So we could also write it, rate is equal to your delta, meaning change in, final minus initial, of some reactant or product. Remember, the brackets indicate concentration, moles per liter, often just indicated by molarity, and change in time. Time unit, usually seconds, but it could be minutes or any other time unit. To determine the rate, you need to know the change of your concentration and the time period. Our units again, moles per second, which, remember, I just said moles, but it should be molarity per second, which is the same as moles per liter per second, which can be combined to moles over liter seconds. And often we see it with the L-1, S-1. All of those units are equivalent, so play with them till you're comfortable. So let's calculate the rate of disappearance for A. So with this, let's look at time 0 when A has an initial concentration of 4, and just go to the end of the reaction when time is 20 seconds and our concentration is 0. So remember, rate is your change in concentration. It's going to be the disappearance. We'll put the negative in for now, and then we'll talk about it a little bit. So the final concentration of A at 20 seconds, I'm just going to indicate it like that, minus the initial concentration of A over the time at 20 seconds minus the time initially. So our final concentration of A is 0 minus 4 molar, because remember, those brackets mean molarity, or moles per liter, divided by our time at 20 seconds, of course, is 20 seconds, minus 0. So when you do your math properly, we have a 0.20 concentration, and we could just go to 1 sig fig because of the time unit, and then our units are molarity over seconds, or I could write it 0.2 moles, liters minus 1, seconds minus 1. An instantaneous rate can be found from a graph by drawing the tangent to the curve. So if we look at this top one, the blue triangle, first the tangent is drawn to the curve, and then we just find the slope of the tangent. So in this example, we have the rate at 2 different spots to show us the change in concentration of dinitrogen pentaoxide. It's called instantaneous because it's the rate at that moment in time. Another interesting equation is how to find and compare the rates between reactants or products. So I've just given you one reactant and one product, but this would hold no matter how many reactants you had or how many products you had. And the rate is going to be equivalent when you take the inverse of the coefficient times the rate for that reactant. And in this example, it would equal the inverse of your coefficient for your product times the rate for that product. Usually we don't use our negatives and positives. We just describe it as rate of disappearance for a reactant or rate of appearance for a product.